This project is sponsored by PCBWay. From July 1st to July 31st, 2026, PCBWay is organizing 12th anniversary campaign. Grab your discount and unlock more rewards in the form of exclusive coupons, PCB orders for just $5, Trunky electronic design services, up to 50% off for 3D printing and CNC machining, and special sales in PCBWay store. Join the fun with interactive games and receive your exclusive engineer color personality. Click the box to participate in the lucky draw, show your colorful projects and vote for the most popular badge. Order now and get big discounts. Hello, ADS-B is the modern standard for tracking aircraft. It has largely replaced traditional radar as the primary method of air traffic control across the globe. In one of my previous videos, I describe a way to receive and decode ADS-B signals via an RTL SDR dongle using a special antenna and software. In this project, I built a fully functional real-time aircraft tracking radar using an ESP32 based 7-inch HMI display. The system visualizes live air traffic data with a smooth rotating radar sweep, just like professional radar systems. ADS-B signals are collected via free online APIs and displayed on the radar in real time. So we only need Wi-Fi connection and internet. These signals contain the following information: call sign, altitude, speed, aircraft type, and position. Each aircraft appears on the radar only when the rotating sweep line passes over it, creating an authentic radar effect. The detected aircraft are also listed on the right panel, sorted by distance. A huge advantage in making this project is the fact that it uses the ESP32 S3 Crow Panel 7-inch HMI display, which means that there is no need for any soldering and making a corresponding box. Physically, the device is actually an Elecro Crow Panel 7-inch HMI display, which costs around $30 along with the acrylic case. It consists of a 7-inch LCD display with capacitive touch, ESP32 S3 microcontroller that controls the display. Next, USB, speaker and battery interfaces, GPIO, I2C and UART ports, as well as micro SD card slot. Specifically in this project, I use only the Wi-Fi option, but always through the rich selection of input-output interfaces we can use it for many other more complex projects. First, let's go into a little more detail on how to install the software. According to the manufacturer's instructions, we need to install ESP32 Core version 2.0.14. Then in the board manager, we need to select board ESP32S3 dev module. Now we need to make a few settings for this board. USB CDC on boot should be enabled. Flash mode QIO 80 MHz. Flash size 4 MB. Partition sham huge. And PSRAM OPPSRAM. Then through the library manager, we need to install the latest versions of the Lovian GFX and PNGDEC libraries. By the way, the libraries that I used are given in the end of the project. Next, the code is installed. It is given in a format that should immediately compile and upload without any errors. Now let's move to the most interesting part, that is to describe way it works and the options. After connecting to the network, the radar display appears immediately. In the upper left corner is shown the number of currently detected aircraft at a distance of 100 kilometers from the home position. In the lower left is a small compass showing the cardinal points. In the lower right, the current sweep position visually and in degrees, and in the upper right corner the number of aircraft in each ring. First ring is 20 kilometers, then 40 kilometers, 60, 80 and 100 kilometers from the home positions. Centrally we have smooth rotating radar sweep with fade effect. Each aircraft appears on the radar only when the rotating sweep line passes over it, creating an authentic radar effect. The small dash on each circle shows the direction of the plane's movement. The color of the circle, i.e. the plane, shows the current altitude. Greater than 3000 feet, blue color. Greater than 10,000 feet with green color. Greater than 0 feet, yellow, and unknown altitude with red color. The detector aircraft are also listed on the right panel, sorted by distance. It can be noted that in the northwest region, at the distance of about 100 kilometers from the home position, we often have aircraft at very low altitudes. The reason for this is that the nearest airport, Tirana, is located exactly in that place, where planes often take off and land. The status is updated every 360 degrees, which is approximately 15 seconds, but this time can be shortened to 1 second. The update moment is indicated in the upper left corner. On the right side of the display we have more information. At the bottom, in large numbers, is shown live local time with NTP synchronization, and above it the home position with the given coordinates, latitude and longitude, and the name of the home place. At the top is information about the 10 closest detected aircraft. For each aircraft individually, more information is given: call sign, distance from the home position, next flying altitude, then moving speed, as well as the aircraft type. On the far right is a circle with the appropriate color depending on the altitude. And finally, a short conclusion. This project demonstrates how an ESP32 and real-time ADS-B data can be combined to create a smooth and realistic air traffic radar display. It's a great example of blending embedded systems, aviation technology and custom graphical interface into a fully interactive real-time project.